Driving Environment, Lecture Number 5. Objective. The objective of this lecture is to understand different driving environments like night, fog, storm, rain, and the effective ways to deal with them to stay safe on the road. These are the main modules which we will discuss in this session: night driving, fog and storm, rain and floods, different times of day, natural forces acting on all vehicles. Let's discuss how to drive safely at night. Driving at night. Driving at night is another aspect of driving which is more challenging than during the day. It demands more focus, special techniques, and extra precautions. One of the obvious reasons is darkness. 90% of a driver's reaction depends on vision, and vision is severely limited at night. During the daytime, drivers can see and feel the objects in their central and peripheral vision respectively. This is due to the sunlight. At night, driver vision is restricted because there is no natural source of light, and they have to totally depend on the streetlights for visibility. Due to less visibility, the risk of both fatal and injury crashes are higher at night for all motor vehicle drivers. However, the risk is much greater for inexperienced or young drivers. Now let's discuss how the visual system works and eyes see at nighttime. How eyes work. If you ever wonder how you're able to see, you may find out with the help of this video. The visual system.
Your eyes allow you to see the world around you, but have you ever wondered how they work? First, it's important to know that vision depends on your brain as much as on your eyes. Your eye's main job is to detect patterns of light. Then, they work with your brain to turn those patterns into images. Let's take a closer look. Light rays bounce off an object you are looking at. Let's say the object is a dog. The light reflects off the dog to your eye. Then, the light enters through the outer part of your eye, called the cornea. The cornea is clear like a window. It helps your eye focus the light to make things look sharp and clear. Next, the light rays pass through an opening called the pupil. The pupil is the dark round circle in the colored part of your eye. The colored part is called the iris. It controls how wide the pupil is and how much light can pass into your eye. In bright light, the iris narrows the pupil, reducing the amount of light that enters the eye. In dim light, the iris widens the pupil to let in more light. All of this happens automatically. Behind the iris is the lens of the eye. It helps focus the light coming into your eye so you can see things clearly. The lens flattens so you can see things that are far away, and bends so you can see things up close. When the lens, cornea, and pupil are all working together properly, they will focus light on the back of the eye. That's important because lining the back of the eye is the retina. There are about 130 million tiny cells in the retina that are sensitive to light. When these cells detect light, they turn it into electrical signals. Those signals eventually make their way through the optic nerve, which is like a cable connecting the retina to the brain. The retina helps create a rough image, but it sees the world upside down. It's your brain that turns what you see right side up. Also, when you look at an object, each eye gets a slightly different view of the world. The brain combines those views and makes them into one picture. The brain also adds a lot of details to your vision, so that you can see complex shapes, movement, depth, and a rainbow of colors. And of course, the brain connects your sense of sight to things you already know, so that when you see a dog, you recognize it as a dog, and not a cat or a monkey. And that's how you're able to see.
How do our eyes see at night? Our eyes let us see an incredibly wide range of lighting conditions due to different parts of the eye working together. The vision range comes from three parts of the eye: the pupil, rod and cone cells, photopigments. To learn more about these parts of the eye, you may click to play or skip. The pupil. The eye, in many ways, is like a camera. The camera's aperture is the part that expands and contracts to let in more or less light. The pupil works in a similar fashion. It will get very small in bright light to physically block the amount of light reaching the retina and will open wide in the darkness. Rod and cone cells. Our eyes use two different types of cells to see light: rods and cones. The cone cells perceive fine detail and color, but need bright light in order to do so. It is called photopic vision. Rod cells can only see black and white and have poor resolution, but remain sensitive even in very low light. It is called scotopic vision. Mesopic vision occurs in intermediate lighting conditions and is effectively a combination of scotopic and photopic vision. Photopigments. Both rods and cones contain light-sensitive chemicals called photopigments. When exposed to light, photopigments go through a chemical reaction that converts light energy to the electrical activity our brains know how to interpret. Rhodopsin is the photopigment used by the rods and is the key to night vision. Color affecting visibility. Primarily, the human eye can function in varying light conditions due to adaptation, which is the ability of the eye to adjust to various levels of darkness and light. The two types of visual adaptations are light adaptation, dark adaptation. Light adaptation occurs when we move from the dark into bright light. It takes approximately 5 to 7 minutes for the eye to adapt to bright sunlight from darkness. Dark adaptation occurs when going from a well-lit area to a dark area. For example, if we go from the outdoors on a bright sunny day into a very dimly lit room, we are hardly able to see our surroundings at first. As time goes by, we gradually become able to detect the room's contents. The eye takes approximately 20 to 30 minutes to fully adapt from bright sunlight to complete darkness. It's much faster for our eyes to adapt to bright light than to adjust for the darkness. For this reason, at night, motorists are unable to see the objects or other road users that are in dark colors. Therefore, other road users, specifically the cyclist and motorcyclist, should wear a brightly colored helmet and fluorescent clothing or strips. They can use dipped headlights even in good daylight to make themselves more noticeable. Along with visibility, there are many other reasons that increase the risk of driving at night. They include depth perception, color recognition, and peripheral vision are compromised after sundown. Reduced ability to judge speed and distance. Vulnerable road users such as pedestrians, cyclists, and bikers are often not clearly visible to the motorists. There are more fatigued drivers on the road after a hard day of work. Less time and space to react as the vehicle lighting cannot illuminate very far. Increased distractions, as often night driving is for recreational purposes. Now let's see how to drive responsibly at night. There is much that drivers and riders can do to minimize the after-dark dangers. The effective measures include eye adaptation, use lights smartly, avoid bright lights, back off, scan, and be alert. Eye adaptation. The most obvious danger of night driving is decreased visibility, so take steps to speed up the process of adaptation to dark. Before going into a dark area and risking bumping into something, close the eyes and cover them for a while to let them adapt. Also, applying slight pressure on the eyes with the palms can help speed up the adjustment process. Remember, the interior lights or the dash lights on maximum can compromise the forward vision. Avoid interior lights while driving and keep dashboard lights at dim for better outside visibility. Use lights smartly. Vehicle lights are there for drivers' safety and for those around them. It is illegal to drive at night without fully functioning front and rear lights. Drivers should also check that all lights on the vehicle are in full working order, kept clean, and aimed in the right direction before starting the journey. In fact, it is a good idea to get into the habit of having headlights on more often than not. The law says you must use the lights of your vehicle from sunset until sunrise, as well as during the day where the view is unclear. The lights must be on the front and the rear of the car. Article 63, Executive Bylaw, UAE Federal Traffic Law Number 21, 1995. Moreover, during times of bad weather, consider using lights regardless of the time of day. Thunderstorms, for example, can bring in dark clouds that turn the sky almost as dark as night. Drivers can use the headlights on high beams to see further ahead, but they should only be used on highways without streetlights, when view is not clear enough. High beams can dazzle other drivers, so dip to low beam when there is an oncoming vehicle on two-way road and when approaching another vehicle from behind on one-way road. Avoid bright lights. Looking directly at a bright light can greatly increase the amount of time the eyes need to adjust to the darkness. Therefore, when driving at night, drivers should avoid looking directly at high beams coming towards them. Instead, they should look to the right side of the road and drive towards the right of the lane to stay on course. If drivers are being dazzled by the lights of vehicle behind, they should use the day and night or anti-glare positions of the interior center mirror. The night position reduces glare from headlights of vehicles behind. Drivers may flip the tab on the bottom edge of the mirror to select the day or night position. In modern vehicles, night mirrors can be used to reduce the possibility of being dazzled by the lights of the vehicle behind. Back off. In darkness, it is harder to judge the speed and distance of vehicles. The objects can be closer than they appear or traveling faster than anticipated. Moreover, drivers should prepare themselves for any unexpected challenge. Therefore, they should back off, which means drive at a speed that allows them to spot hazards and react accordingly. Maintain a safe following distance that is double compared to daytime. For example, for light motor vehicle, 4 seconds instead of 2 seconds. For motorcycles, 6 seconds instead of 3 seconds. For heavy vehicles, 8 seconds instead of 4 seconds. Scan and be alert. The best way to avoid an incident at night is to be watching for lights and movements. Motorists can stay alert by checking mirrors regularly to be aware of the surroundings. At night, it is more important to scan for other drivers' mistakes than having to worry about your own. One way to scan better and stay alert is by making sure windshield and mirrors are clean. Windshields that appear clean during the day may reveal streaks that can cause glare at night. Bike riders should make sure that their visor is scratch-free and clean. Similarly, dirty mirrors reflect the lights from vehicles behind in a wider, diffused shape that can produce glare in the eyes. Therefore, motorists must make sure that the mirrors are clean and are pointed in the direction that will make it easier for them to see. Tip: obey the road laws at all times and remember to be prepared for the mistakes of other drivers.